Alrighty, fresh start to a new month. Okay, I'm going to try to do even better from now on. Better. Right, push dominoes. There are n dominoes in a line, and we place each domino vertically upright. In the beginning, we simultaneously push some of the dominoes either left or right. After each second, each domino that is falling left pushes the adjacent domino on the left. Similarly, if the domino is falling on the right, push the adjacent dominoes on the right. When a vertical domino has dominoes falling on it on both sides, it stays still due to the balance of the forces. For the purposes of the question, we will consider that a falling domino expends no additional force to a falling or already fallen domino. Okay? You're given a string dominoes representing the initial state. Okay. Return a string representing the final state. Okay, so there's 4 dominoes. Initially, this one's falling right, this one's falling right, this one's falling left. So the right one doesn't really apply anything to the right one here. The left one applies. Okay, so this middle one is pushed by both the right and left, so it stays the same. Okay, so here, pure graphical representation. So this one's going to be left, period for same, right. Okay, this appeared right here. Left, right, left, same. Okay. Okay, dokie. I'm gonna have an array of characters that I'll eventually convert to a string. And I think what makes sense here? How long is this string here? 10 to the 5th. So this almost certainly should be a 1-pass solution. It can't be n squared solution because 10 to the 5th squared is just too long. Takes too long. I think what makes sense is a stack. So if you have a domino, if it's falling left or right, then it's the final version of it should say that falling left or right. And if it's a standstill domino, then if it's closer to the nearest right fall, then it becomes right. If it's closer to the nearest left fall, then it becomes left. Otherwise, it's the same. Okay. So can I code that? So if I know for each spot, if I'm doing a 1-pass, what I sort of just need to know is where the next opposite direction is. So where the next left is. Because I should already, in that 1-pass, know where the nearest right is. Okay, so let's determine, okay, for each index, determine where the next left falling domino is. So I think that would be, I think you would want to go backwards in the array. So for each index in the range n minus 1, -1, -1, where n is the length of the number of dominoes. I'll have let's go ahead and make it called next left and be an array. So the next left, yeah, I guess -1 is fine, times n. So say the last left is currently n. I don't know if that really makes sense. Okay, I need to figure out what the initial condition should be, but it should track basically where the last left that it saw is. So if the current domino at this index, so dominoes at this index equals left, and then the last left is this index, and then I store at this index in the array this value. Okay, I'll print out this to make sure that it's working correctly. Okay, so 0, 1, 2, 3. So the next left is 3, the next left is 3, the next left is 3, and the next left is 3, sure. So the next left is 14. I wonder if I should make that -1. Because there is no next left. I don't know. 14, 14, 14 is like this one, 13, 12, 11. So the next left's 11, 11, 11, 11, and then 7, 7, 7. Okay, I think that's what I want. Okay, so then if I actually try to compose the answer array, it's for each index in the range of n. So this is passing. Easier to create using backwards iterating loop, and here we're going to go forward loop. Create answer string. So for each index, okay, so if the dominoes, I do need to have a last right, and I'm going to say the last right is should this be -1? Yeah, maybe this should be -1. Alright, so if dominoes at this index, so let's say the val is dominoes at this index. If the value is not equal to a standing, then it's going to keep whatever it is. So I'll do answer.append this value and continue. So here value is a which is a standing domino, which means I need to determine if closer to right or left. Right on the right or left on the left. So actually, if the value is a dot, then I also need to update if it's a right. If the value is equal to, this is horrible. If the value equals right, then the answer to append right, and the last right is this index. Else if the value is a left, answer append left. Yeah, I don't know about this. Else. Okay. So here, so the next left is so if the difference between this index minus the last right is smaller than the next left for this index minus this index, then it's closer to the next left. But it could be -1 as well. There's a lot of if statements here. So it's -1. Although if there is a left, so there's a left, this left affects these. No, so what am I thinking here? If you had something where you had a right falling one, a right falling one, and a left one here. Falls to the right, falls to the left. Like this right and this left cancels. Yeah, this right and this left cancels. And this thing is not going to be affected by this left at all. So this thing doesn't have a next left. So the last left is L. Else if Dominoes at this index is a right, then the last left becomes -1. Like there's no left influence. Yeah. Any right would reset the left influence. Okay. So here, there's going to be like a lot of -1 possibilities. Is there a way to simplify the logic here? So if they're both negative ones, then they're both negative ones. Okay. I can say if so maybe I'll call this right index. To clarify that this is different from the left index, which is last left at this spot. If maybe I should just make two arrays, then I don't have to worry about this logic. Yeah, I don't know. If right index is equal to -1 and left index, I mean, if they're the same, then they're the same, right? So if they're both -1s, in which case they're the same value. Then there's no influence. Then the values answer.append -1. Else if right index is equal to -1, then the answer append a left. Else if the left index is -1, then answer.append a right. Else it needs to append the closer of the two. Else else if the index minus the right index gosh dang it, now you have to do the difference. Okay, so let's do diff is the difference between how close this is to the nearest left versus nearest right. So it should be something like left index minus index. So that's the difference between the left side versus index minus right index. I should be able to simplify that. So that simplifies to be index cancels. No. So negative. So that'd be -2 index. Jesus Christ. Okay, whatever. I think it's fine. So if the difference is equal to 0, then answer.append the stationary one. Else if the difference is positive, then it's closer towards, there's a bigger difference to the left side, so it's closer towards the right side, so it should append right. Else it should append left. Okay. And then it should return the joining of this thing to a string. Okay. I wonder if this is the correct syntax. Answer dot. Left index, last left at this index. Did I not? Print out the last left. Oh, it's supposed to be next left, not last left. Next left at this index. Okay. So this should be, yeah, I screwed up on the way that the indexing works here. So if you see a right, if you see a left, then the right index should reset to be -1 because it doesn't influence anything past that left. Okay. Okay. So it's decent, but it could be faster. So how can I make this faster? So I make an array where I determine where the next left is. That should be pretty fast. I wonder if this is better if it was instead of using characters, no, it's using integers. Okay, so making it so it knows where the next left thing is. And then there's a lot of if statements here. Just a lot of convoluted logic. I'm going through the right side. I think this is necessary to differentiate between left versus right. If the value is right, append to right. If the value is left, append to left, but then reset the information. The value is right. Change the right index to be this index. Values left, change it and also reset. Otherwise, look at the nearest left index. If they're both the same away. They're both the same away. Then append dot. Do. They're both the same away, append a dot. It's only nearest a left. Trying to think if I can do something fancy to mess with this logic to make it easier to make this determination. So if I were to have a so this thing is nearest left is going to be nearest left will be for this spot should be 1, and then that should be 1. Nearest left there should be 0, -1. This would be -1, and then this would be -1, -1. What if I just did the distance to the nearest left? What if I stored the distance? And the distance can at most be n. But then if the distance can be at most n away. Oh. The distance be at most n away. So store the distance. I guess keep track of the distance. Alright. Let's say it's actually n for the next left. No, so let me just do some separate code here. Distance, let's say left distance is going to be n times n for each index in range, n minus 1, -1, -1. And let's say distance is starting with n. So I'll say Dominoes at this index is equal to left, then the distance is 0. Else, if Dominoes at this index equals right, then the distance equals n. Oh my gosh. So the distance is always going to increase by 1 each time. So if it's a period it's a left, then you set the distance to 0. If it's a right, then you set it to n. If there's a period, then what do? If it's a period, then you increase your distance by 1. And then dominoes at this index is equal to the distance. And then if you go the other way around, so the other way around, you'd have to have a right distance. I'll say this is our distance is equal to n. Maybe I should make this maximum of distance in n. Okay, so for each index in range n, L distance is the, oops, what am I doing here? Left distance at this index is the maximum distance, and L distance is going to be the left distance at this index. And you have some logic for the R distance. So if dominoes at this index equals right, then the R distance is 0. Else, if dominoes at this index equals left, then the R distance is set back to n. Else, distance increments by 1. The distance equals the max of the distance plus 1 and n. I have my left distance is that, and now I can just do a straight comparison. Yeah. So if our distance minus L distance is greater than 0, then answer.append. So it's closer towards the left. Else, if our distance equals minus L distance is equal to 0, answer append dot, else answer.append of right, and return the join. Okay. Okay, so it's a pretty significant incorrectness. So let's go ahead and point out what's going on here. So the distance to the nearest left, ooh, that's really wrong. This should be 0. This should be like 1. So if the index is left, the distance is 0. Oh, it should be min here. This should also be min probably. Okay, so this is 0 from the left, 1 from the left, and this is arbitrarily just the largest from the left, so it's 4. Okay. And on the right side, this should be 0, 0, and this should also be 1, I think. So when it hits that point there, the distance should be 1, I think. Oh, it's r distance. What am I doing? Not distance. R distance plus 1. Okay. Is this any faster, or is it the same speed, or slower? Slower. Okay. Well, the convoluted logic ends up being faster. Convoluted logic ended up being faster. Else, if else. Jesus. I guess there's 2 guaranteed if statements here, and there's only 1 guaranteed if statement here. I guess the simpler case of it being R or else is handled maybe better there. Maybe I should just do something like, if it's a right domino, then the R distance is 0. Answer pen right. Continue. Answer pen left. Continue. And this thing could also just be left distance at this index. L dist. Right, this should still work identically. It does save on the second if statement. In theory, not in practice. I guess maybe the minimum here isn't that great there. So it's left dominoes right. Find the next domino. Find the next left domino. I wonder. build work here. Every index. Every index. See how close that is to the next right index. They're the same. The right index is -1. If the left index is -1, and then find the difference. Oh well, okay, that's it. I'm done. Don't know if it's worth it to try to find something better. Yeah, the logic is just this logic is just it is what it is. Okay. Summary. Create an array to track what the next left index is that would affect the current one. And that's this thing right here. Note that if there is a right left falling dominoes, if there's a right falling domino between now between here and next left, then it negates its influence. Same, so after you create that, do a forward pass loop where you keep track of the closest right falling domino index and determine the current domino based on that and next left. Right. Basically you use, well, I use very convoluted logic to make and a bunch of if statements, if else statements to make the exact determination. Like if there is no left influence and there is a right influence, then it's the left. If there is no right influence but there is left influence, it's the right. If their influences are the same, then it's a dot. Or if there's no influence at all, then it's a dot. So on and so forth. Time complexity, this is O of n. To create the next left array and answer array, and also to join the array of characters to a string. Space complexity, this is O of n. To have the left arrays and I'm not sure how you would consider a string. I mean, the string is of length n, but that's necessary for the space of the answer. But of n for the